We talked about scientific notation. We practiced how our calculator works. We also, half the battle, hopefully you found, is being able to interpret how your calculator displays stuff. So last day, Justin, I showed most of you how to make your calculator display answers in scientific notation. Now, if you're finding in math, it's displaying everything in scientific notation, and that's bugging you. Later on in this lesson, I'll walk you through in more detail on your calculator how to flip from one mode to the other. I just did it really, really quickly last lesson just so I could get the number to appear on your screen, but I didn't have time to show you how to memorize the procedure and just do it yourself. And again, this is why it's so important that you bring your own calculator, just saying. So we did scientific notation, and we practice typing them into our graphing or our calculator or whatever we have. The second skill we want to look at is what's called dimensional analysis or unit conversion. This is actually useful. Out of everything that I do in this first unit on math skills to survive, this may be the one thing that you might use in the future. And too much of schooling that we show you is useless, but I'm not in charge of the curriculum. So, there are two main types of unit conversion questions. There are one-step and two-step. One-step is where you're going from a metric prefix, the big M there, to the base unit. Now, the base unit is the one that has no prefix. So when I talk about a base unit, I mean grams, or seconds, or meters, or joules, or something, a single letter. That's the base unit. But if it's two letters, if it has a lowercase or uppercase letter in front of it, that's going to be a metric prefix. So we have to be able to convert from one to the other. And the first one says, convert the following. It says, convert 12. What does the big capital M stand for according to your yellow sheet? You don't need to memorize this. It's on the back of your yellow sheet. Find that chart of metric prefixes. Big capital M is what? Mega. Mega. So I want to go from 12 megagrams to grams. I start every single, I am big on, and you guys don't know this yet, I want to give you a similar approach that you can use to every question so that at least on the first step, Thomas, you don't have to think. It's a habit, and then after that, you've got to think. And so anytime I'm doing a unit conversion, my first step is always, I write down what they gave me. So with your pen or pencil, underneath here, write 12 megagrams. I always do that. Also, Amy, I'm big on getting you to write something down because once you write something down, Justin, the question is no longer blank. I've learned as soon as the kids write something down, their test scores go way up. It's no longer blank. Their brain starts flowing into their arm a little bit, and somehow they just know what to write. So, trick of the trade. What do we want to end up with? What's the G stand for just by itself? Grams. This is a one-step question because we're not going from one prefix to another prefix. We're just getting rid of the prefix. How do we do that? Well, the short way is to simply replace mega with its power of 10. I'm going to write 12, and I'm going to write the word times. According to your chart, what is mega the same as? As a power of 10, 10 to the what? So I'm going to replace the mega with 10 to the 6th. And I've now converted it to grams. Of course, I'm not going to leave it like that. I'm actually going to type this into my calculator. Now, this looks like scientific notation because there is a power of 10. It is not scientific notation. This time, I am not going to use my scientific notation button. I'm going to get my calculator out. All of us are going to get our calculators out. And I'm actually going to type 12 times 10. And for most of you, your exponent button probably looks like a little hat, a little, well, it's the Shift 6 on a keyboard. It's a Calais if you want the fancy thing. It looks like that, 6. And if you press equals, you should find that you get a 12 followed by 6 zeros, which you might have been able to do in your head. If you can't find your exponent button, now is the time to ask. The exponent button, by the way, is not EXP. EXP is scientific notation, which stands for something totally different. So you need to find this little thing. On some of your calculators, it may be, instead of that, it may be x to the y or a y to the x. Probably on my cheaper calculators, that's what it's going to be, just saying. But if you can't find your to the power of, now is the time to ask. Anybody need help finding their to the power of button? Go once, going twice. So 12 megagrams is, we'll write our answer up here, 12, 1, 2, 3, 4, 5, 6, comma, 12 million grams. Now that may seem, especially if you've done chemistry already, fairly straightforward, but what I'm trying to show you is a method that will also get us through yuckies, through nasties. Example 2. 13.6, what's the lowercase m stand for according to the chart? Milli. This is 13.6 milliamps. Okay. By the way, if you play around with electricity, 13.6 milliamps is actually enough to cause your heart to fibrillate and kill you. So just be aware. It's called, the milliamp is actually called the death current because it can cause your heart to palpitate. Back to physics. You know what I'm going to do first? I'm going to write down what they gave me. This is a one-step conversion. How do I know? Because we're starting with a prefix and we're ending with just the base fundamental unit of amps. By the way, just to show you the difference, in a two-step conversion, you're starting with one prefix and ending with a different prefix, and that's going to take a bit more work. But that's how you can recognize it. You can say, oh, I'm starting with K and I'm ending with that funky thing. I'm starting with N and I'm ending with that funky thing. So 13.6 milliamps is 13.6. What is milli? 10 to the what? You have to go look on your chart, please. (13.6 milliamps is the same as 13.6 times 10 to the negative 3. And again, Spence, although that sort of looks like scientific notation, it's not. Also, scientific notation, the decimal would be after the 1. I'm not going to use my scientific notation button. I'm going to go 13.6 times 10 to the power of negative 3. And I get that. Apparently 13.6 milliamps is 0.0136 amps. Mr. Dueck, do we have to put the 0 in front of the decimal point? No, it's optional. I usually do, but I won't take marks off if you don't put it in front. There certainly has to be a 0 right there because it is 0.136 on your calculator after. Yeah? Okay. 2 steps. 2-step questions. I want to introduce to you the idea of building a conversion chain. A conversion chain. And this is the useful skill that can bail you out an awful lot and let you get away with a lot less memorization. So it wants me to change 13.6. What does a lowercase k stand for? Kilograms into, what does that funky symbol stand for? Micro. Okay, it's a Greek letter mu. Looks like this. Greek letter mu. For what it's worth. Can you see, Max, why it's a 2-step? We're going from one prefix to a different prefix. My base unit is grams. Okay. You know how I'm going to start? Darn right, there. Brilliant. Write down what they gave me. And now I'm going to multiply. And what I'm going to multiply by is a fraction. Don't panic. And the fraction that I'm going to multiply by is kilograms on the bottom, grams on the top. Now, why did I do that? Because ideally, if I set this up correctly, this kilogram and this kilogram will cancel. That's why, since kilograms originally were next to the 13.6 and on the top of a fraction, because technically it's all over 1, I put the kilograms in the bottom of the next fraction, and I matched it with its base units. Now, this is going to sound confusing. Don't panic yet. What's kilo the same as? Kilo on your chart, what's that the same as? 10 to the what? What I'm going to do is I'm going to put the 10 to the 3 next to the base unit, and the 1 goes down there, although the 1 is optional. You can just leave it blank. What I'm saying is 1 kilogram is 10 to the 3 grams. That's called a conversion factor. This is in grams. What do I want to end up in? Micrograms. Okay. I'm going to multiply by another fraction. That's why this is a 2-step. I want to get rid of the grams. Where is the grams in the middle fraction, on the top or the bottom? Meant to be really obvious. Where is the grams in the middle fraction? On the top or on the bottom? On the top. So if I want it to cancel, where am I going to put grams in the next fraction? Bottom. And I want to change it into micrograms. So I'm going to put micrograms on the top. It's going to seem confusing at first, but when you wrap your brain around it, this works great for almost anything. And 1 microgram is, the conversion factor is the power of 10 from your chart, and that always goes next to the base unit. It doesn't go next to the prefix. So what is micro? 10 to the what? 10 to the negative 6? That's going to go down there. And notice, Carson, grams cancels. First of all, let's look at the units. This is called unit or dimensional analysis. Kilograms canceled, because there's 1 on the top and 1 on the bottom. Grams canceled, because there's 1 on the top and 1 on the bottom. What are the only units that are left behind? Micrograms. What did I want to end up in? That tells me I've got my chain set up right. Now, how am I going to type this in my calculator? Anything on the top, I times. Anything on the bottom, I divide. It's going to be 13.6 times 10 to the third times 1 divided by 1. If I times or divide by 1, does that make a difference at all? So don't bother typing that, but I'll usually write it. Divided by 10 to the negative 6. On my calculator, Amelia, it's going to look like this. 13.6 times 10 to the third divided by 10 to the negative 6. Try typing that on your calculator, please. 13.6 kilograms is this many micrograms. And it's going to be a big number. You may even get an answer in scientific notation. It'll be close. I get an answer in scientific notation. 1.36, and on my calculator, and this is why, again, Justin, you have to memorize how your calculator works. On mine, whenever I see a capital E shrunk down like that, I know that stands for times 10 to the power of 10. 1.36 times 10 to the 10th micrograms. Anybody not get that on their calculator? And you should have the same power of 10? Okay. This is called building a chain using a conversion factor. It's a hugely useful skill. I'm going to try and convince you of that during this lesson. Number 4. Lowercase n stands for what? Do I have a lowercase n on your chart? Yeah? Okay, lowercase n stands for? Nano. Uppercase M stands for, we did that, that was mega, right? So this is a two-step conversion. Hey, how am I going to start? Alexa, you're right. How am I going to start? Yeah, write down what they gave me. And you're going to find all year long, anytime I introduce a new concept, almost always I'm going to try and give you a standard approach, start here, and then start thinking. But I want to give you that kickstart. I'm big on that. So I'll go to black this time. 2,000 nanoliters. By the way, for liters, I always make my L a written L. Why don't I make my L like that? What does that look like too much to me? A 1, and I'm stupid, I'll get confused later. So you're going to notice I almost always will do liters that way, just to be paranoid. Times. What units am I in right now? Nanoliters. I want to get rid of them. How will I get rid of them? I'm going to put them on the bottom, and I'm going to put just plain old liters on the top. This is the first step. I go from nano to liters to mega. Nano, what's that? Where does it go? Next to the base unit. In fact, really what we're saying is this, Spence, if you're looking to remember where the power of 10 goes, what I'm really saying is on the bottom, that little n is the same as a 10 to the negative 9. So this is nanoliters, this is nanoliters, but instead of writing the n, I wrote the power of 10 there. And what I've just done is I've converted from nanoliters to liters, if I just type that in, if I went 2,000 times 10 to the negative 9. But I'm not done. What do I want to end up with? What units do I want to end up in? Megaliters. What am I in right now? Liters. Where is that liters? On the top or on the bottom? Right now, where is the liters? On the top. Where am I going to put the liters in my next fraction then to get it to cancel? On the bottom. And I'll put megaliters here. What's the conversion factor for mega? Is it 10 to the 6th? Where is it going to go? Not next to mega. Mega stands for 10 to the 6th. It's going to go down there. And what this is saying then, Devin, is if you want to go 2,000 nanoliters into megaliters, it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th. Oh, and you'll notice, Kyle, I stopped writing the 1s because they don't make a difference anyways. So in the first one, I mean, if you want to, okay, fine, there's a 1 there and a 1 there, but you're not going to bother typing those into your calculator anyways. So good, try it. 2,000 nanoliters, how many megaliters is that? And I think the answer is going to be pretty small in scientific notation, I think. Because a nano is really, really small, and a mega is really, really big. So how many really, really smalls are in a really, really big? Not much. 2,000 times 10 to the power of negative 9. Alexa, you found where the exponent button is on yours? Yes? I think it's also in the same place above the division sign, right? Divided by 10 to the 6th. Do you get 2 times 10 to the negative 12? Yeah. So 2,000 nanoliters is the same as 2 times 10 to the negative 12 megaliters. And what I'm saying to you here, Nick, is don't memorize the conversions. Memorize or learn the method, and we'll practice this. This idea of building a chain totally cuts down on crap you have to memorize. Because I've had some kids that have tried to memorize how many nanos are in a mega and how many kilos are in a deca. No. I gave you the chart so you don't have to. It takes a couple of lines. By the time you get good at this, it'll probably take you about 2 seconds, which is not worth memorizing for. Try 5 on your own. I'll do it up here. Let's see if we end up in the same place. Oh, write down what they gave me, right? What's going to go on the bottom of my first conversion factor? Kilometers. And just plain old meters on top. Oh, but don't forget to add the conversion factor. There's going to be, oh. I know that kilo is 1,000, so it's 10 to the third on your sheet. Sometimes you'll see me just write 1,000 because I've done, kilometers is about the only one that well, kilometers and centi. Those are the two that I've memorized, because centimeters and kilometers. Meters on the bottom, millimeters on the top. That's going to cancel the meters. I need the conversion factor. Carson, what's milli? 10 to the negative 2? Negative 3? So it's going to be times 10 to the third divided by 10 to the negative 3. I think. You get, I think I'm going to write that in scientific notation. I think it's going to be 3.42, 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 3, 4, 2, 5, and 5 zeros, I think. Get that okay, Spence? Or did you zig?
No, I got the equation right. It's just on the calculator. I did it wrong.
Okay. By the way, that's also why you're going to hear me preach all year. During the lessons, practice typing this in, because believe it or not, you're going to be using your calculators an incredible amount this year. That is also a skill. You get better at stupid typos, avoiding all that stuff. You also, again, you learn the idiosyncrasies of your particular calculator. I can't emphasize that enough, which is why I get grumpy when people forget theirs at home. Shut up, Mr. Dueck. Sorry. Is that right? Yeah, 3, 4, 2, 5, and 5 zeros? 342.5 kilometers is 342,500,000 millimeters. Not that I really care, but there you go. Okay? That's for metric. Now, metric is nice because they're all powers of 10. Mr. Dueck? Yeah, Thomas? Shouldn't we actually always only be going to 1 sig fig in all of our answers? Because we're multiplying, and 10 has 1 sig fig. Ah, that's a brilliant question. Because the metric conversions are defined and exact, we don't use them in our sig fig calculations. We do not. Because it's actually not 10 to the power of 3. It's 10.000000 and many zeros. It's exactly 10, because that's how it's defined. So we kind of ignore those for sig fig calculations. Okay? Great question. Brilliant. I could see you were pondering it. And then we have the stupid US system. Nothing is powers of 10s. They have conversion factors for everything. So I wrote down here, multi-step conversions using conversion factors. Okay. How many seconds in 1 week? Does anybody know off the top of their head how many seconds are in 1 week? I don't. I've never bothered memorizing it. Okay. We're going to do this as a chain. How am I going to start, do you think? How have I started every other question? So they want me to change 1 week into seconds. So you know what I'm going to write down first? Ta-da! 1 week times. What can you break a week into? What have you memorized just growing up here in North America? What unit of time can you evenly break? Oh, I don't want that right now. What unit of time can you break a week into? Oh, days, you say? So we're going to use a conversion factor. Where do I want the weeks to appear, on the top or on the bottom of my next fraction? What's the conversion factor? How many days is how many weeks? 7 days is 1 week. This is why I said this. You don't have to memorize how many seconds in 1 week. You've memorized enough to get there already. So now we're in days. Does anybody know how many seconds in a day? No? Don't bother. What can I break days into? How many hours in a day? There's my new conversion factor. So I'm going to go multiply again. Kyle, where do I want to put the days in the next fraction? On the top or on the bottom? Yep. What am I going to put on the top? And what was the conversion factor? 24 hours, 1 day. So what we're saying right now is if you wanted to go from weeks to hours, you'd go 1 times 7 times 24 divided by 1 divided by 1, although I wouldn't bother doing the ones on my calculator. Let's keep going. Does anybody know how many seconds in an hour? And this is where sometimes people know. No? That's fine. Don't memorize it. What can I break hours into? Minutes? Oh, that's a good unit of time. Where am I going to put hours in my next fraction? And minutes on the top? What's the conversion factor? How many minutes is equal to how many hours? Does anybody know how many seconds are in a minute? Ah! This is the one that I do know. So rather than memorizing how many seconds in 1 week, which is a waste of time as far as I'm concerned, I already know that there's 24 hours in it, and I know there's 7 days in a week, and I know there's 60 minutes in it. That's enough that I can just hopscotch my way there with a tiny bit of thought. So I want minutes to cancel. Seconds on the top. What's the conversion factor for seconds and minutes? How many seconds is how many minutes? And look at our units. What's the only units left on top still standing? We've done it. How? What are we going to type in our calculator? Ignore the ones. What am I going to do in my calculator? Divided by 1, divided by 1, divided by 1, divided by 1. Why are they doing that? Now, you may have been able to already do that, but this method will bail you out of stuff that's way, way tougher as well. This is called building a conversion factor chain. It's called dimensional analysis. So if I go 7 times 24 times 60 times 60, how many seconds are in 1 week? 604,800? Oh, always add the units. Seconds. How many hours in a year? Does anybody know how many hours are in 1 year? No? Okay. Let's see if we can build a chain with stuff we've already memorized. What do they want me to end up in? What did they give me as a unit? Years? How am I going to start? Write down what they gave me. And by the way, I could also just as easily say how many hours in 2.6 years, right? How many hours in 3.9? I could still handle it. This method that I'm giving you, Devin, is very, very, very flexible. So you know what? I would start out by writing down 1 year. Okay, what can you break a year into? Days? Sure. So let's put year on the bottom. Let's put days on top. 365 days, 1 year. And Carson, the years would cancel. Do we know how many hours in a day? Oh, yeah. This is only going to be a 2-step chain. I hope you guys know how many hours in a day, right? Where am I going to put days? On the bottom? Hours on the top? What's the conversion factor? How many hours make up how many days? Okay. 1 day. I guess it's going to be 301 times 365 times 24 divided by 1 divided by 1, but I'm not going to bother using the ones. Every year, you are 8,760 hours older. Multiply that by your age, and you can find out to the nearest year how many hours old you are. Most of you are 17, some of you are 16, some of you are 18. I am 394,200 hours on July 31st of this past summer. Then I could add the number of hours since then if I really wanted to be nitpicky. So I'm approaching 400,000 hours old. Wow. Almost 500,000. Yeah, I'm that old. Oh, what did I say we always add at the very, very end? The units. So what are we in right now? I will be fussy this year. If you don't put units on the final answer, you'll lose a half mark. Okay. How many seconds in 1 year? Now, before we go, I'd like you off in the margin somewhere to take a guess. How many seconds old do you think you are? I'm not going to mark this or anything, but this is my, remember I showed you that mega penny trying to get you used to big numbers and small numbers? Somewhere off in the margin, best guess, how many seconds old are you? And if you want to, just go to your age to the nearest year. And then what we'll do is we'll find out how many seconds in 1 year. We'll multiply that by your age at the very end. You can see how close your guess is. Okay, here we go. Ooh, did you hear Carson? Carson said, well, I already learned there's 600,000 in 1 week. So he's already he's trying to break it down to an easier unit to work with. Absolutely. This is why we have different units, because on that mega penny project video that or website that I showed you, as soon as the numbers get big, we can't wrap our brain around them. We really can't. So you ready? Let's find out 1 year. What am I going to do first? Write down what they gave me. What did they give me? Seconds or 1 year? 1 year. They want me to end up in seconds. So 1 year. Does anybody know how many seconds are in 1 year? And the reason I ask is I think there's a song from Rent that tells you how many minutes are in 1 year. And every couple of years, I have a student who's seen the musical and has memorized the song and knows the conversion factor. So does anybody know the musical Rent and know the song? Okay. Oh, it's something like 321,900 minutes is the song. Something like that. We'll find out. Anyways, every so often, I have a kid who can rattle it off, and okay, you've memorized something that I haven't. You have a shortcut that I don't bother using. What can I break years into? Who said, what was that? Did you hear Devin? He didn't even say days. What did you say? Why? We just made our own conversion factor on the previous question. Why don't we tie into something we've already done? And instead of going days and then, let's go straight to hours. How many hours make up 1 year? 8,760. Brilliant. We saved ourselves some time. But again, Devin, if you were doing your homework later on and you couldn't remember that conversion factor, you already have enough. You all know 24 hours in a day. You all know 7 days in a week. You all know 60 seconds in a minute. You all know 60 minutes in an hour. What can I break hours into? Minutes? Okay. So Devin's pretty sharp. He's memorized another conversion factor. And this one probably you will end up memorizing as the year progresses, because we measure speed on the freeway in kilometers per hour, but we measure speed in physics in meters per second. So he's saying, Mr. Dueck, I know there's 3,600 seconds in 1 hour because it's 60 times 60. Do you guys want to take that shortcut? Or do you want to go hours and then minutes? I'm fine either way. You can, since you haven't memorized. Go ahead. Spence says, let's go hours first. Okay, so we'll go hours, minutes up here, 60, cancel, cancel. And then I want minutes to cancel. Seconds here, 60. Spence, can you see what Devin did? He said, hey, Mr. Dueck, I can combine those because 60 times 60 is 3,600. So I can go from hours to seconds. Fair enough. That's an optional one to memorize or not on your formula sheet. That's like, it's handy. But you can certainly survive without it. Okay, how many seconds in 1 year? 8,760 times 60 times 60. Uh, 31,536,000. 3153630. 3153630 seconds, comma, comma. So if you multiply that by your age in years, that's how many seconds old you were on your birthday. I've got to know. Thousand, million. I'm approaching 1.5 billion seconds old. Wow. And I have to admit, like, everything within me wants to give my age in weird units of time when, like, I'm at a security stop or giving my ID or age. 1.5 billion seconds, please, ma'am. But that would, get me searched in the private room with harassment. But I think it'd be funny. Okay. Anybody here? So I don't think any of you are 1 billion seconds old yet, but probably most of you are around, what, 300 million? Sorry, yeah, around 300 million, 400 million seconds old. Is that what it is? 500 million. Oh, so you're approaching 500 million seconds old. Doesn't that make you feel like gray-haired and old? Okay, sorry. Then we have the stupid US system. Do not memorize these. If I ever ask you to convert to Imperial, I will give you conversion factors. So I gave you this information, and I asked, how many centimeters in 1 mile? The first thing I'll go look for is there anything on there that relates centimeters to miles or miles to centimeters? Go hunting through there. Because it'd be nice if that was the case, I could use it. Nope. So, what are they giving me? 1 mile? What do I want to end up in? Centimeters? How am I going to start? Always, how am I going to start? Write down what they gave me. So I'm going to go, the abbreviation for mile can't be an M, because what does an M stand for in the metric system? So the abbreviation for mile, how about 1 E? What can I turn miles into? What conversion factor did they give me? They hopefully gave me at least one. Degrees, don't worry about. That's for latitude and longitude. Think distance lengths, and don't use nautical miles. That's for ocean navigation. The one below degrees, Spence. What a stupid conversion factor. How many meters in a kilometer? 1,000. How many centimeters in a meter? 100. How many feet in a mile? Oh, 5,280, sir. What a stupid conversion. I've never memorized that. I know it's a little over 5,000 is all I know. Because I did grow up pre-metric. But what a dumb conversion factor. So there's my conversion factor. Where's miles going to go, top or bottom? Bottom. Where's feet going to go? Top. What's the conversion factor? 1 mile is 5,280 feet. How's that help? Can I go from feet to centimeters? Is there a conversion factor for that? Don't see one. Okay, what can I go from feet to? And this one isn't on there. This one you may just have to have up here because you've grown up close to the States. You know how many inches are in 1 foot? 12. Again, a stupid conversion factor, but at least a little better than 5,208. Okay, so you're saying, Justin, that I can put feet on the bottom, inches on the top, and you're saying 12 inches is 1 foot? And can you see what we've got now? Well, what units would this be in right now? Inches. What do we want to end up in? Please tell me there's a conversion factor relating inches to centimeters, I hope. Is there? Ah! Sir is a nice touch. That helps. Never hurts to suck up to the system. So you're saying inches there, centimeters there. What's the conversion factor? How many centimeters is how many inches? By the way, what if the 2.54 was on the bottom? That would just mean on my calculator I would divide by 2.54. I just noticed all of the examples that I've been giving you have had ones all along the bottom. Sometimes you'll end up with a number on the bottom because that's the way they gave you the conversion factor. That just means divide. For now, how many centimeters in 1 mile? 5,280 times 12 times 2.54. 160,934.4. 160,934.4 units. Centimeters. This is kind of my throwing the mic down. I write the unit. I did the conversion. Ta-da! Centimeters. There you go. Walk off the stage. Now we're going to do a multiple unit conversion. What is 60 miles an hour in meters per second? What do they want me to end up in? What are they giving me? How am I going to start? Are you spotting the pattern? Right? Write down what they gave me. Now, slash is like a fraction, so I'm going to write it like this. 60 mi over hours, because that way I can clearly see what's on the top and what's on the bottom. And what we're going to have to do is we're first of all, or somewhere along the way, going to have to change hours into which unit of time? Seconds. And we're going to have to change miles into which unit of distance? Meters. We're not going to do them both at the same time. What do you guys want to do first? Hours to seconds or miles to meters? Doesn't matter. Max, pick. Do you want to do the distance part or the time part first? Distance first? Okay, so I want to get rid of miles. Where am I going to put it? Because it's on the top originally. What can I change miles into? Now, Devin is probably saying to himself, I could have gone to centimeters because I actually have miles to centimeters on the line above. I'm not so sure how much faster that would have been, so I'll use the longer conversion factors. Okay, Max, what can I change feet into? And this one's not on the chart. This one we kind of have to memorize because you grew up close to the U.S. What's the unit of measurement you can break feet into? Inches. So feet on the bottom, inches on the top, 12 inches, 1 foot. What can I change inches into? Centimeters. 2.54 centimeters is 1 inch. Hey, what can I change centimeters into? Ta-da! Right? Meters. And that's, Max, what we wanted to get our distance unit. Okay, we can do this. So centimeters on the bottom. Now that's from my chart of my yellow page. Centi is 10 to the what? -2. Where's it going to go? On the always next to the base unit. It goes there because we're replacing the C on the bottom with the 10 to the -2 on the top. They're the same thing. Okay. Want to give me a little elbow for me? Wakey, wakey, eggs and bakey. That gives us Meters. Now let's do the time. Don't start typing yet, Max. We're going to do this all in one fell swoop. I'm not typing twice. Put your calculator down. What time unit did they give me at the very, very beginning? Hours. What do I want to end up in? Okay. Where is the time unit? On the top or on the bottom in the original fraction? Bottom. So to get it to cancel, when I multiply, where am I going to put hours in this fraction? You see it? This time, Noah, it has to go on the top to cancel out the hours that were on the bottom. And seconds, do you remember how many hours, how many seconds were in 1 hour? 60 minutes times 60 seconds, 3,600. We'll use that shortcut because you guys are kind of zoning out on me. Hours cancels. Now look very carefully at what units are left. What are the only units left on the top? Right there. Meters. What are the only units left on the bottom? Second. This is meters per second. Apparently if I go 60 times 5,280 times 12 times 2.54 times 10 to the negative 2 divided by 3,600. And that may seem like a long chain. I'm telling you, it's better than memorizing all this crap. You can. I'm not going to bother. 60 times 5,280 times 12 times 10 to the negative 2 divided by 3,600. Now, I have to admit, I'm enough of a nerd that I've memorized a rough conversion factor from miles per hour to meters per second. I know that miles per hour is roughly twice as big as meters per second. So before I hit equals, I'm guessing you guys got an answer somewhere between 25 and 35. Am I right? I hope. That's my, if I'm on the road trying to figure out how fast I'm going in meters per second. And of course, why wouldn't you be doing that when you're on the road? That's my rough conversion factor. Well, oh, wait a minute, I'm wrong. 10.5, I missed something. 27, let's say. Units, meters per second. Okay. Let's win the lottery. Next page. When I first created this, I think this was the all-time record for the biggest lottery win. I haven't double-checked to see if it's been beaten recently or not. But in 2002, Andrew J. Whitaker won $314,900,000 in the Powerball lottery. Come on, you've all wondered about stuff like, if he spends $1,000 a day, how many years will it take him to spend his money? What unit of time do we want to end up with? What's this question asking me to find? Years. Years. Okay. I think the first thing that we need to do is well, let's go like this. We're going to start out by going 314,900,000 divide it by 1,000 because that'll tell us how many days he has. Right? If you spend $1,000 a day, that'll tell us how many days he has to spend the money. And I think I can do that in my head. Dividing by 1,000 just lops off 3 zeros, right? I think you're going to find that he ends up with 314,900 days. Let's convert that to years. We start out by writing down what they gave us. Do I know the conversion factor to go from days to years? Hey, yeah, I do. What? How many days is how many years? So we're going to put days on the bottom, years on the top, and 1 year is 365. Like I said, sometimes the conversion factor ends up on the bottom. If he spends $1,000 a day, can he spend it in his lifetime? How many years? Yep, one too many. 300 divided by. Oh, can he even come close to spending it in his lifetime? Nope. Nope, 800. Let's call it 863 years. Because when you have that much money, rounding off probably doesn't make a big difference. I did some more Googling. Actually, that was the prize before taxes. So after taxes, he got that much. What if he spent $5,000 per day? How many years would it take him? Well, let's take this 114 million and divide it by $5,000, first of all, to change it into days. 1, 2, 3, 1, 2, 3, divided by 5,000. Okay, now we're talking 22,800 days. Is that right? Double check me. Anybody else get that? Because I might have missed a zero. 114 with 6 zeros divided by 5,000. Is that right? Yep. Okay. How many years is that? So let's write down what they gave me. 22,800 days times 365 days is 1 year. Oh, divide that by 365. If he spends $5,000 a year, can he spend that in his lifetime? Sorry, $5,000 a day. I said a year. A day. Barely. Depending on how old he was when he won this. If he won this when he was 50, if he won this when he was 20, he'll be 82, so maybe. 60, what did I say? 62.5 years. You've wondered with some of those big grand prizes just how much money you could spend, right? Again, we don't wrap our brain around big numbers very, very well. That's a lot of money. So the homework is lesson 4. Homework, but let me tell you which ones I'm going to assign. First of all, let's shrink this down a little bit. And then I need to talk a little bit about it as well. Certainly, number 1, fair game. You want to reach the point where scientific notation becomes almost as easy as regular numbers. Not quite, but close. Okay? Number 2. Number 3. Number 3, using your calculator. Okay? Number 4, I haven't quite done a question like this, but if 1 electron weighs that much, how does that much... I'm going to assign number 4 to see if you can figure it out. Kids almost always ask me this the next day, and I don't mind going over it the next day. I'm going to pass on number 5. What does number 6 want me to find? Area of a rectangle. I'm just going to make a little note here. The area of a rectangle is length times width. What I'm really asking you to do is multiply 2 scientific notation numbers together and get comfortable with your calculator. So I'm going to assign number 6, skipping number 7. Unit conversions we come to if you turn the page. Number 1. Number 2. Number 3. And then suddenly we start jumping around. Skip 13 anyways. See if you can figure out 14. I haven't done one quite like that, and so I don't mind going over it with you next class, but I'm always trying to give you a couple of questions in the homework to see if you can have that aha moment to figuring it out yourself. Oh, yes. One of Mr. Camosi's ancient Italian ancestors was a chicken farmer who wished to purchase a wife. At the time, the going rate for a wife was 2 horses. However, 3 horses were valued at 5 cows. 1 cow was worth 4 hogs. 3 hogs were worth 4 goats. 1 goat was worth 9 chickens. How much was the wife going to cost the farmer who had to pay in chickens? There's enough conversion factors in there, and I apologize, ladies, but it seemed like a humorous question. I think you can do the conversion factor to convert wives to chickens. And again, I apologize, ladies, for that one, but it's a good conversion factor question. If you don't know how to do it, again, I'll go try it next class. And then last little bit. Enrico Fermi, these next 2 are optional, but Enrico Fermi was a physicist who would often ask his students to solve a problem by making reasonable assumptions about unknown data. The idea was to provide a reasonable mathematical argument for your answer. I'm not marking these wrong or right. I want to see if you can give me an argument that your answer is pretty legitimate. Here's the first one. If Pitt Meadow Secondary, you know what? Actually, we will look at these on Monday. So these 2 I'll assign you guys Monday because I want to teach this properly and I have a video and I don't have time to show it. So for 10 minutes, and I was hoping to give you more time in class, I apologize. You can work on these. This is not going to be officially due Monday because I hate giving homework over a long weekend. I'm going to collect this on Wednesday, but you are going to be getting more stuff Monday probably. On Monday, the take-home quiz that I gave you a couple of days ago by mistake, I'll be assigning that on Monday. So I said earlier that the take-home quiz was due Monday. Take-home quiz is not due Monday. Try and use this next 10 minutes to get as much of these done as you can, and the rest we'll work on Monday. I don't want to give you homework over a 4-day weekend, okay?